Algebra 1 students, welcome to today's lesson 7.4. This is the final section of Chapter 7 before we move on to our test next week. You've done a good job so far, so let's make sure we pick up everything here and we'll be ready to go. All right, first of all, the big idea. We're talking about division properties of exponents. And here's the concept. If you were to take 4 to the 5th and divide by 4 to the 3rd, another way to say that is 4 times 4 times 4 times 4 times 4, that's 5 of them, divided by 4 times 4 times 4, that's 3 of them, and you'd get those 4's canceling, those cancel, and those cancel. All you're left with is two 4's right here, 4 to the 2nd. Another way we could get that is 4 to the 5 minus 3 power, and that's the direction we're going to actually go with this, is using subtraction. The other option is we have 7 to the 2nd divided by 7 to the 6th. You can see it laid out with all the 7's here. Now again, we're going to jump straight to this 7 to the 2 minus 6 power, if you really know what you're doing, which is 7 to the negative 4. Now of course we write that with a positive exponent, so we write it as 1 over 7 to the 4th. And you can see the general form right down there, a to the m over a to the n is a to the m minus n. Now this may look familiar, but remember we've seen a couple of other properties. We had a to the m times a to the n, and in that scenario we added exponents. The other thing we saw was a to the m, where you took the power of the power, and this is a to the m times n. So we've got three different things that we're really keen in on for this chapter, at least the first half of it. All right, so here we go. Let's do some simplification. 3 to the 8th divided by 3 to the 6th. Since these do have the same base, we can go ahead and apply that property. That's 3 to the 8 minus 6 power, which would just simply be 3 squared, or 9. Let's try another one. Number 2, x to the 5th divided by x to the 7th. That's x to the 5 minus 7 power, or x to the negative 2. Now, of course, we want to get rid of that negative exponent, so we'll write it as 1 over x squared. All right, on number 3, we actually have two problems to deal with here. We have a's, and that's going to look like a to the 3 minus 5 power. Again, you take the exponent from the numerator and you subtract the denominator's exponent, times b to the 2 minus, and don't forget there's like a little implied 1 right there. So what we have then is a to the negative 2, b to the first, or you can just write it as b. Now again, we don't want to stop there because we don't like negative exponents. We change it to b divided by a squared. All right, the next one here, this is an interesting one. As I look at it, I almost wonder if I forgot to put the rest of the problem on here, but we'll just roll with it. It's fine. X to the negative 1 times x to the negative 3. All we'd have to do in that case is just move both those terms to the denominator. Now, as I said previously, that problem doesn't exactly fit into this section. It is a new problem, but it's okay. It's never a bad thing to go ahead and practice things that we've done before. All right, so let's move on. Number 5. I actually have three problems I need to deal with here, and I'm going to kind of separate them. I'm going to have 16/12. Is one thing I need to work with. I'm going to have a to the negative 3 over a to the 2nd, and I also have a b to the 6th divided by a b to the 3rd. Now let's deal with these one at a time. 16/12. I know 4 goes into each of these numbers, so I'm going to rewrite that as 4/3. A to the negative 3 divided by a to the 2 is another way we could write that as a to the negative 3 minus 2 power. And then here we'd have b to the 6 minus 3 power. Now as we work on simplifying that, I'm going to have 4/3 times a to the negative 5 times b to the 3rd. Now one thing I want to do again is get rid of any negative exponents. So I'm going to go ahead and rewrite this a little bit as 4b to the third divided by a to the fifth. Oh, I left something off there. Did you catch it? There's a 3 over here. All right, so 4/3 is there, b to the third is there, and a to the negative fifth, which we've moved to the denominator, make it a positive a to the fifth. All right, let's take a look at number 6, a little scientific notation for you. Now, again, we basically have two problems. The first problem is 5.6 divided by 7, so you could think of that as problem 1, 5.6 divided by 7, times, and then we're going to have 10 to the negative 7 minus 3. Now, let's go ahead and work on simplifying. 5.6 divided by 7 works out somewhat nicely. It's 0.8, and then we're going to have times 10, and negative 7 minus 3 is negative 10. There's only one issue with the answer that I have right here. It's this number, 0.8. If we're going to write in scientific notation, let's do it right. So I need to multiply this number by 10 so I can move that decimal one spot over. So again, remember, I just made this number bigger than it used to be, which means I need to make this number over here smaller so that I haven't changed the value. So this is 10 to the negative. I need to go down one step, so negative 11. All right. Very similar question on number 7. I'm going to again treat this as two separate problems. 7 divided by 8 times 10 to the, and we'll go 4 minus negative 3, which I can just write as plus 3. Now you might need your calculators for this, but 7/8 is 0.875. And to get it into this scientific notation, we'll write it like this. Again, hopefully you guys are noticing we have an issue with our scientific notation. This number is not between 1 and 10, so we need to change it. That's 8.75 times 10. All right, real quick, we made this number bigger, so I have to make this number smaller. The number that's smaller than 10 to the 7th would of course be 10 to the 6th. So these are our answers that you see here. All right, we have a couple more problems left. Kind of summarizing some of the things we've done. I think they're good ones to finish up with. Now I'm going to treat these, I'm going to deal with these one step at a time. And the first thing I want to address is that negative exponent right there. I'm not going to mess with anything else yet other than I don't like having negative exponents. So let's get rid of them. Very simple change. All I've done is reciprocate my fraction. So instead of 2x squared over 5x cubed, it's now 5x cubed over 2x squared. And the exponent that was negative 2 has become positive 2. Now we have a choice at this point. You could apply the exponent to each term. I actually think it might be easier to go ahead and simplify our x's first. So I'm going to have 5/2 times x to the 3 minus 2 power. Remember, that whole thing is still going to be squared. So what I end up with is 5 times x to the first over 2 quantity squared, which finally would equal 25x squared over 4. One more to make sure we understand what's going on here. This time, let's try this one differently. Instead of applying or dealing with the exponent out here first, let's work inside first. It's just a matter of preference. The first thing I see is 9 over 36. I'm going to rewrite that as 1 over 4. T to the 2/3 divided by t is t to the 2/3 minus 1 power. Now remember, this whole thing is raised to the third. All right, so let's work on simplifying things a little bit. Right now it looks a little scary. T to the 2/3 minus 1 would be t to the negative 1/3. Remember, this whole term is still cubed. Now I'm going to rewrite this one more time where I actually move that t to the negative 1/3. I'm going to move that down to the denominator so that I have only positive exponents. My last step now is to go ahead and cube each of the terms. The numerator is 1 times 1 times 1, which will just leave us with 1. 4 cubed, well 4 times 4 is 16. 16 times 4 is 64. And then we have to deal with this one, t to the 1/3 cubed. Now this is a power of a power, so what we would have there is t to the 1/3 times 3. And if you're thinking about what 1/3 means, you would know that when you multiply 1/3 times 3, you would get just simply a 1. So that is 1 over 64t. Come to class, ready to work, and let's finish this quarter off strong. Have a great day.